In intermediate algebra, sections 7.1 through 7.3 are considered review sections. So they're things that you've seen in previous courses, but it might be good to go over them a little bit. So I'm going to kind of move my way through some of these examples here. If you find that there's certain sections that you're struggling on a little bit more, take a look at the examples in the textbook or work on some of the examples that I'm skipping here, and that'll give you a better idea of some of the things that you need before you move on to the material in the rest of the chapter. But for the most part, you should remember this from a previous course, and maybe just seeing it again, maybe I'll do some of the harder problems on here, will help you to be ready. So a rational expression is a polynomial divided by another polynomial. So for example, my x squared plus 1 over x minus 3, they're both polynomials, they're divided, therefore it's a rational expression. We can have numbers that are rational numbers. For example, 4/3 is a rational number. Both the numerator and denominator are integers, and I'm dividing them. All right. In my example that I gave you with the x squared plus 1, the denominator can't be 0, right? You can't divide by 0. We saw this when we were doing slopes of lines earlier in the course. So in that expression I gave you, x can't be 3, because otherwise you'd end up with a 0 in the denominator. So how do you simplify these things? Well, if you can divide out a common factor, you can simplify. Now, I said you can only cancel factors. Don't try to remove terms that are added. So, for example, if you have like a 2x plus 4 over 2x plus 7, you can't just cancel the 2x's because they appear top and bottom. Don't do that. If you were able to factor something out in common, like you had a 2x plus 4 over 2x plus 8, and you said, oh, I can pull a 2 out of the top, and I'm left with an x plus 2. I can pull a 2 out of the top, and I'm left with an x plus 4. And now I can remove that common factor of 2 top and bottom, and here it is simplified. All right, it's not much simpler than when we started, but at least it's done correctly. All right, let's take a look at a couple of these. Look at number 3. I got a 12 minus 6x on the top and a 5x minus 10 on the bottom. The first thing you think is you look at the top and you see you got a common factor of 6. So you pull out a 6. 12 divided by 6 is 2. Negative 6x divided by 6, negative x. Down the bottom, they both have a 5 in common. So I pull out a 5. 5x divided by 5 is x, minus 10 divided by 5 is 2. Well, these factors look pretty close, but they're not exactly the same thing. Look at that 2 minus x that's up on the top. What if I pulled out a negative out of that 2 minus x? I'd get a negative 2 plus x, and now look, it matches down the bottom. So another way to look at this is instead of pulling out a 6, what if I had pulled out a negative 6? Then I would get negative 6 times x plus 2. On the bottom, I would, x minus 2. And on the bottom, I would get a 5 times x minus 2. Now the x minus 2's are common factors that cancel top and bottom, and I get negative 6/5. So if you get a factor that's close, but the signs are both off, pull out a negative 1, and that'll solve your problem. All right, take a look at number 4. Number 4 is two trinomials, that are both pretty easily factorable. All right, so let's factor each one, and then see if any common factors cancel out. We can't just cancel the x squared top and bottom or something like that. We have to factor. So let's factor the numerator. I need two numbers that multiply to be negative 10 to add to be negative 3. So I'm thinking negative 3 and negative 5 and positive 2. So I get x squared minus 3x minus 10. That works. Down the bottom, I need two factors that multiply to be negative 12 and add to be negative 4. So 3 and 4 aren't going to work. They're too close together. How about 6 and 2? With the bigger one being negative, the smaller one being positive. Foil that out, see if it works. I get x squared plus 2 minus 6, so minus 4x minus 12. Always double check your factoring to make sure it works before you go on, because if the factoring is wrong, the rest of the problem goes with it. All right, now these are two things multiplied on the top, two things multiplied on the bottom. They cancel out. All right, so this simplifies to x minus 5 on the top, x minus 6 on the bottom. And this will work as long as x is not equal to 6. If x is equal to 6, this expression is undefined. All right, let's take a look at number 6. Number 6, the factoring gets a little bit more challenging. we've got a 25 minus x squared on the top. We got a 2x squared minus 7x minus 15 on the bottom. So on the bottom, maybe I'll try this just by guess and check. Because it can only be a 2x and an x. Factors of 15, yeah, technically they could be 15 and 1, but I'm going to guess they're probably more like 3 and 5. Question is, which one goes where? I don't know. That's why guess and check is called guess and check, because we guess and then we check. So maybe I'll put the negative here and the positive here. Right, that gives me 2x squared minus 10 plus 3. Okay, there's my answer. Minus 15. Right, if I had swapped the signs around, I would have gotten a positive 7 instead of a negative 7. Then I would have gone, oh, let's switch those signs around. Up on the top, a 25 minus x squared, that's a difference of squares. So it's a 5 minus x times 5 plus x. FOIL it back to make sure, and it works. Now, it looks like right away nothing cancels out, except again, we're going to hit that same thing with the negative that we saw before in the other problem. And that is, look at that 5 minus x. That 5 minus x is the same thing as negative, and then change both signs on the inside, so make it a positive x and a negative 5. Ah, okay. So now something will cancel. So if you get something that's off by both signs, then pull out a negative 1. So let's see how this factors. It factors as negative x minus 5 times 5 plus x. On the bottom, I get a 2x plus 3 and an x minus 5. Well, these are two things multiplied on the top and on the bottom. X minus 5 is a common factor. So on the top then, I get negative 5 plus x, or x plus 5, same thing. On the bottom, 2x plus 3. Oh my goodness, look at number 8. We should tackle number 8. See what happens. First of all, I'm thinking factoring by grouping might help us here. So I'll group the first two, plus group the second two. Don't lose that negative sign that's in there. Down the bottom, I'll group the first two, plus group the second two. All right, so up on the top, I get an x. Here, let me come on the side and work that out. So I get an x times x minus 2a, right? The x comes out. In the second part, I've got a 3x and a 6a. Well, I think I want that x to be positive, so let's pull out a negative 3. Negative 3x divided by negative 3 is x. 6a divided by negative 3 is negative 2a. So then on the top, I get x minus 2a times x minus 3. All right, let's work the bottom out. Do it in different colors so we could tell one from the other. On the bottom, I've got a common factor of 9 and x squared. So let's pull out a 9x squared. And I'm left with an x minus 18 divided by 9 is 2. When the x squares drop, I just have an a. Look at the second piece. For the second piece, again, I think I'd like a positive x. So let's pull a negative 4 out. Negative 4x divided by negative 4 is x. 8a divided by negative 4 is minus 2a. So I get x minus 2a times 9x squared minus 4. And now I can see a couple of things. One is that I can see I got a common factor that cancels. That x minus 2a goes away top and bottom. So I'm left with x minus 3 over 9x squared minus 4. Now, you might notice that the denominator is a difference of squares, right? I could continue factoring the bottom as 3x minus 2, 3x plus 2, but I'm not going to just because nothing cancels on the top. So how do I decide how far to go before I stop? Well, I look to see if factoring any further would allow me to cancel anything else, and in this case, it doesn't. Right, those factors on the bottom would be a 3x and a 2. Doesn't cancel with anything else on the top. So that's how I know when to stop. If the top was like a 3x plus 2, then I would keep going so I could simplify it even more. All right, again, review stuff, kind of moving along here, multiplying and dividing rational expressions. So how do you multiply fractions? Straight across the top, straight across the bottom. So 3 times 5 is 15, 4 times 6 is 24, and then we always simplify. I can take a 3 out of top and bottom, so divide the top by 3, I get 5. Divide the bottom by 3, I get 8. Another option is that you could sort of pre-simplify, if that makes sense, and that is look at my 3 and my 6. Common factor. 3 divided by 3 is 1. 6 divided by 3 is 2. And so now I multiply. 5 times 1 is 5. 4 times 2 is 8. Same answer. Rules for dividing fractions. First one stays where it is. Division sign becomes a multiplication sign. You flip the second. Right? Does it keep, change, flip is what they teach in 5th grade when you do fractions. Here I can do a little bit of pre-simplifying again to help keep the numbers a little bit smaller. I like doing that because it makes them a little bit easier to work with. So notice I've got a 16 and a 4, so I can take a 4 out of this. I can take a 4 out of that. Notice the 3 and the 9 both share a common factor of 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. And now look, straight across the top, 1 times 4 is 4. 1 times 3 is 3. The third one I put on there just to remind you, if you're going to divide fractions, 5 over 36 multiplied by the reciprocal. So this thing is really 125 over 1. So the reciprocal is 1 over 125. My answer is going to be small, right? I can take a 5 out of top and bottom here. 5 divided by 5 is 1. 125 divided by 5 is 25. But then when I multiply across the top, I get 1 on the top. And on the bottom, 36 times 25 is a big number. What is it? 900. Here's my answer, 1 over 900. Because essentially this is saying you're taking 5/36 of something, which is already pretty small, and dividing it into 125 pieces. How much is each piece worth? It's worth 1/900th of the original. So this just reminds you about how to multiply fractions. Multiply straight across the top and across the bottom, and then we simplify. Okay, so the same thing that applies to multiplying integer values that are inside of rational expressions applies to polynomials when they're inside of rational expressions. All right, let's take a look at the second one. The first thing I'm going to do is I'm going to factor this mess. So for number 2, the first thing I'll do is I'll factor. So this becomes factors of 3, same sign, add up to -4, so they both have to be negative. X minus 3, x minus 1. Foil it back and see if it works. X squared minus 4x plus 3, we're good. Down here, I have factors of 20, same sign, add up to -12, so they both have to be negative. We could think of 4 and 5, but 4 and 5 is not going to add up to 20. Or not going to add up to 12. How about 10 and 2? Right, foil that back. X squared minus 12x plus 20. Good. In the second piece, factors of 90 that add up to 19, I'm thinking 9 and 10, both with negative signs. Yep. And down the bottom, the factors have to have the same sign because there's a plus. It's got to be 9 and 1. Minus 1, minus 9. Good. All right, so look, I got 4 factors on the top, and I got 4 factors on the bottom. Because I'm multiplying, I could write all 4 of them across the top and all 4 of them across the bottom. But first thing is, let's see if anything cancels. Let's see if anything goes away. So I've got an x minus 9 over here and an x minus 9 over there. They go away. I've got an x minus 10 over here and an x minus 10 over there. They go away. I got an x minus 1 over here and an x minus 1 over there. They go away. Oh, look, I'm only left with 2 factors left. An x minus 3 on the top and x minus 2 on the bottom. All right, so that was probably the most complicated of the 3. The other ones, similarly, you can factor out common factors and work from there. All right, if you're dividing, again, that keep, change, flip thing that worked for the numerical examples I did before works for these rational expressions with polynomials too. All right, take a look at the second one, let's say. X minus 11 squared over 2 divided by that second piece. So if we're going to do a keep, change, flip thing, let's do x minus 11 squared over 2 times 4 over, well, 2x minus 22. I can factor out a 2, and I'll be left with an x minus 11. So I change the division to multiplication. I flip the second term. What can I get rid of? Well, look at this. 2 times 2 is 4 on the bottom. That cancels with the 4 on the top. One of the x minus 11s down here cancels with one of them on the top, and I'm left with just x minus 11. All right, how about number 3? Let's take a look at number 3. First thing I'm going to do is factor the numerator here. So factors of 60 that add up to negative 16 that have the same sign, how about 6 and 10? So x minus 10, x minus 6. So I FOIL it back, I get x squared minus 16x plus 60. When I rewrite it, it looks like this. X minus 10, x minus 6 over x minus 10 times the reciprocal of that second term. So that second term is really x minus 6 over 1. So when I flip it, I get 1 over x minus 6. All right, so what happens? We can cancel a few factors here. We've got an x minus 10 top and bottom that goes away. We got an x minus 6 top and bottom that goes away. Uh-oh, what happened to the whole problem? It just didn't disappear, right? It just doesn't become nothing. It becomes a 1. When you have the same factors top and bottom, it just becomes a 1. Because you realize here, if I had canceled out the x minus 10 to begin with, I would have gotten the problem as x minus 6 divided by x minus 6, which is just 1. All right, one more thing in this review section, which is adding and subtracting fractions. And the examples here are adding and subtracting fractions with the same denominator. The new material that we're going to cover in the next section is adding and subtracting them with different denominators. So if they have the same denominator, then just combine the numerators by whatever operation you're given and simplify. So take a look at the second one over here. You've got an x over x squared plus 7x plus 10 and a 5 over x squared plus 7x plus 10. When you add them together, you get x plus 5 over x squared plus 7x plus 10. If I were to factor this, I'd get x plus 5 times x plus 2. Oh, so it simplifies a little bit, right? I have an x plus 5 on the top, and on the bottom, I have x plus 5 times x plus 2. The x plus 5s cancel, and I get 1 over x plus 2. So if it's possible to continue and simplify as far as you can. The trickier one is when you have to deal with subtraction, because that negative sign that's before the second fraction applies to everything in there. So sometimes it's helpful to put that set of parentheses around it. So yes, your denominator is x squared. Your numerator is 6 minus x minus 6, right? The negative gets distributed to both terms in there. So that gives me a negative x on the top. 6 minus 6 is 0. I can knock an x out of top and bottom, so I'll get a negative 1 on the top, x on the bottom, and I'm done. All right, again, same deal over here. So I can see my common denominator is already set up for me. It's already x squared minus 1. So I get a 2x minus x. 2x minus x is x. That's the easy one to see. The second thing you're going to get is negative 3 minus a negative 4. Negative 3 minus a negative 4 is plus 1. Now, it turns out the bottom of this fraction factors. It's a difference of squares. X minus 1, x plus 1. So we're left with an answer of x plus 1 over x minus 1, x plus 1. which means we're not done yet because we have to get rid of the x plus 1 factor top and bottom, and we're left with 1 over x minus 1. All right, one more and then we're done reviewing. Then we'll get to some new stuff. This says subtract simplify to lowest terms. Again, that negative sign applies to everything in the second piece. So we get 7a minus a plus 2, right? Minus a negative 2. On the bottom, common denominator is already set up. So 7a minus a is 6a. So we get 6a plus 2 over a plus 2. That's as far as it goes. We can't simplify this anymore because you notice there's nothing to factor out of the bottom. I mean, we could take a 2 out of the top, but it really doesn't help us much, right? Factor out a 2, 6 divided by 2 is 3, so we get 3a plus 1. On the bottom, a plus 2. That's really not any simpler than the first one is. So you could leave it as 6a plus 2 over a plus 2. Please don't try to separate them. You can't separate fractions with a denominator that has a sum of two terms, in this case, an a plus 2. All right, in the next section, we will talk about what we do with fractions that do not have the same denominator.